This is part 3 of section 8.4. We are getting into some more difficult problems. We have a lot of things to simplify. I have radicals that are going to need to be simplified. I have fractions that I hope to be able to combine. I have a lot going on. The first thing I'm going to do is I'm going to try to simplify these radicals, and I'm actually going to use this property in both directions. Okay, so I have a fraction under a radical, and one of the things I notice is that I have a perfect square in the bottom. And if you recall, one of the things we're not allowed to have in a simplified radical is a radical in the denominator. So that means this is going to go away nicely. However, the square root of 98 is not, so I'm going to use this in the opposite direction. I hope it will be clear. So the first thing I have is 9 times the square root of 48 over the square root of 25. Okay, I've taken this fraction under the radical and split it into 2. Minus 2 times. What I'm going to do here is I'm going to put this back as a fraction under the radical. And I think you'll see why in a second. Okay, I've used the same property in 2 different directions. So what I have right here is 9 times the square root of 48. We've done a couple of times. It is going to be 4 times the square root of 3 over the square root of 25 is 5. And this is 9 over 1 here. Okay, minus 2 times. What I'm going to do here is I'm going to reduce this fraction. If you divide both of those by a 2, you get 1 over 49. And I think you can see the advantage here. We both know the square root of 1 and we know the square root of 49. So this is going to simplify pretty easily. Okay, so what do I have right here? Okay, I have 9 times 4, which is 36, square root of 3 over 5, minus 2 times, think of splitting this up, the square root of 1 is 1, the square root of the square root of 49 is 7. So this is 36 times the square root of 3 over 5 minus 2/7. Okay, now we need to get a common denominator and combine them. With 5 and 7, our easy common denominator will be 35. So I multiply both of these by a 7 and multiply both of these by a 5. Okay, now 36 times 7 is 252 times the square root of 3 over 35 minus 10 over 35. Now combine across the top, I have 252 square root of 3 minus 10. Make sure that this radical bar does not go too far over. You don't want the minus 10 to look like it's underneath. And this is over 35. I would reduce this fraction if I could. The only thing I could factor out of these two to try to reduce would be a 2, and 2 doesn't reduce it with 35. This is your answer. We're not allowed to combine these because this one doesn't have a square root on it at all, much less one that matches this one. So this whole thing is our answer. It's kind of ugly, but it's better looking than that. Okay, so let's try this one. 3 times the cube root of m to the 5th over 27 minus 2m times the cube root of m squared over 64. Okay, so what I'm going to do is I'm going to split each of these radicals up, top over bottom. So this is 3 times the cube root of m to the 5th over the cube root of 27 minus 2m times the cube root of m squared over the cube root of 64. Okay, so let's simplify this one. I have 3 times. 5 is larger than 3, so this will simplify. 3 divides into 5 one time with a remainder of 2. So that means I'm going to have a m to the first power on the outside and then cube root of m squared on the inside. And this is over. The cube root of 27 is 3. Minus 2m times, this is over 1, this is over 1. That will help me in a second. 2 is smaller than 3, so that does not simplify. The cube root of 64 is 4. Okay, let's simplify these. The 3's here will reduce, so that first one is simply m times the cube root of m squared, and this is minus 2 and the 4 reduce to just a 2 down here. So I have m times the cube root of m squared over 2, or I could also write it as 1/2 m times the cube root of m squared. Now, why did I write it like that instead? Because it's easy for us to say, okay, well, 1 minus 1/2 is 1/2. That's one of the fraction subtractions we can usually do in our head without getting a common denominator. But you could go through getting a common denominator in everything. What you would get is 1/2 m times the cube root of m squared, which is the same thing as m times the cube root of m squared over 2. Those are equivalent. They're both equally good. Okay, so let's do the last problem in this section. Okay, we have the square root of 8 over 9 plus the square root of 18 over 36. Okay, so I have the square root of 8 over the square root of 9 plus the square root of 18 over the square root of 36. Now, these are all things we have done before. The square root of 8 is 2 times the square root of 2 over the square root of 9 is 3 plus the square root of 18 is right here. It's 3 times the square root of 2. And the square root of 36 is 6. Now we're going to need a common denominator. So I'm going to multiply this by a 2 and this by a 2 in order to get a 6. So that's going to be 4 times the square root of 2 over 6 plus 3 times the square root of 2 over 6. I have a common radical here. I have a common denominator, so I can add the 4 and the 3 to get 7 times the square root of 2 over 6. I looked to see if I can reduce this fraction, and the only thing I could even potentially reduce is the 7 and the 6, and they don't. Remember that this is not a 2, it is the square root of 2. It is 1.4 something forever. Not anything to do, cannot reduce with this 6. This is your answer.